Hello, hello. Here we're looking at arrays and factors. This is from Unit 1, Module 3, Session 4. It says, draw and label, here's question 1, draw and label a rectangular array, here's an example of a rectangular array, to show two factors for each number. Do not use one as a factor. Now, just as a little bit of a warm-up, we know that our prime numbers only have one and another number, right? So an example of a prime number would be like 1 times 7, okay? That equals 7. That's the only way we can get 7 is by taking 1 times 7. And we would have to draw our rectangular array in 7 pieces. 2, 3, 4, is that 7-ish maybe, hopefully? 1 times 7, okay? Now, since it says that we cannot use 1 as a factor, that means that all of these numbers that we're going to do have to be what? What's the word? Composite. Okay? So, if we have a prime number, the only way that I can split that number up is 1 in itself, 1 times itself. But a composite number is going to have 1 times itself and one or more others. Okay? So, check out this first one that they did for you. The number was 8, and they decided to say, well, 2 times 4 is 8, so they went 2 tall, 4 wide, they drew it, and then they did 2 different arrangements of it. 2 times 4 is 8, and if you flip it, you get 4 times 2, also 8, right? We know that the order doesn't matter. You still get the same answer. Then they decided to take 8 divided by 4 to get 2. So if you take 8 and you divide it into 4 equal pieces, each of those are 2. And then they took 8 divided by 2 to get 4, which they switched the quotient and the answer. Okay? So, check it out. We have the number 16. A couple different ways we could do this. I could take 2 times 8. The same would be 8 times 2, right? I could take 4 times 4. And it really doesn't matter if you flip-flop. You still get the exact same thing. So, let's do 2 times 8. Okay, so I'm going to do 2 tall. And this will be kind of challenging, but that's okay as far as drawing. Okay, so it's 2 tall. Right now it's 2 tall. And then I'm going to split it into 8. So let's split that. So now I have 2. Split each of those. Now I have 4. And if I split each one of those, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I have 2 times 8. Okay, and by the way, you can pause these videos anytime you want to. Alright, so here's 2 times 8, which gives me 16. The commutative property, that's a fancy word that we've talked about before, tells us that if I flip these two around, I still get the exact same answer, because I can either count 2 8 times, 2, 4, 6, 8, 10, 12, 14, 16, or I can count 8 twice. 8 plus 8 is 16. I still get the same answer. Now, how can I take this 16, 16, wow, I need to work on my math. How can I take this 16 and divide it? Well, I just need to figure out where these two numbers need to go. So let's say I take this 16 and I divide it by 8. What number's left? I used the 16, I used the 8, has to be the 2. And that is true. If I take 16 and I divide it into 8 groups, each group's going to have 2 in it. If I flip-flop these, the answer is still going to work out. If I take 16 and I cut it in half, each half is going to have 8. Okay? Now, for the number 18, I'm going to let you do this one on your own, but I'm going to give you a couple options. We cannot do 1 times 18, because that's what the instruction said. You cannot use 1 as a factor. But you could use what? And you can pause this video if you want to come up with these on your own. But you could use 2 times 9. The same would be 9 times 2, right? We could use, how about 3 times 6? And if you flip it, you get 6 times 3. Same thing, right? There's a couple options for you. This one's probably a little easier to draw with the space that you have on the paper. But if you wanted to do 2 times 9, you could make it really long and divide it up into 9 pieces. It's up to you. Okay, but you can pause this video whenever you want to finish this section. I am going to move on to question number 2. List all the factors of each number before. We've done our rainbow factors in class, and this is a great one here that you can see. If you remember, in class we kind of draw clouds, and then for fun, for my crafty kids, we kind of color the rainbow as we go. But we know that for the number 12, I can take 1 times 12 to get 12. That's why it's connected by a line. I can take 2 times 6 and get 12. Or I can take 3 times 4 and get 12. These are all the factors of 12 in order. 1, 2, 3, 4, 6, 12. You always want to start smallest on the left, largest on the right, and you want to make sure that as you split these, I find it easier to start on the outside. So for example, number 16. We know always that 1 and 16 are going to work. Okay, because it's 1 times the number, and you can connect that with your rainbow, right? I can then, since this is an even number, right, it's even, I can have 2 as another factor. I know that. I know it. And I have to figure out 2 times what is 16? 2 times 8 is 16. I can connect those two. And then you just have to use your brain power to figure out if there are any other factors. Is 3 a factor? Well, not really. You can't take 3 times a number to get 16. Is 4 a factor? Oh, yes, because if I take 4 times 4, then I still get 16. Okay? Now, if you could keep working, you could see, does 5 work? No. Does 6 work? No. Does 7 work? No. But there's no point in going above number 8. Okay? Now, let's do one more. By the way, what is this? This is a composite number because you have more than one rainbow. Okay? Now, let's continue. 17. We know, faux show, that 1 and 17 are going to be factors because 1 times the number is the number. We know this, right? And we can connect that using our beautiful rainbow. Now, this is not an even number, right? It doesn't have a 0, a 2, 4, 6, or an 8 at the end. It is not even. So I know that 2 cannot be a factor. So, what about 3? Let's see if I count by 3s. 3, 6, 9, 12, 15, 18. No, that doesn't work. Count by 4s. 4, 8, 12, 16. No. Count by 5s. 5, 10, 15. No. Count by 6. 6, 12, 18. No. Count by 7. 7, 14, 21. No. Count by 8. 8, 16, 24. No. There are no other factors. You get 1 and 17. And if you ever have one rainbow, we know that this number is prime. Now, the instructions don't say to write whether it's a prime number or a composite number, but we're doing it in there just faux fun. Okay? I'm going to let you do these on your own, but can you help me out by doing just at least this? We know that 1 and 24 are going to be our first rainbow. We know that 1 and 9 are going to be the first rainbow. We know that 1 and 36 are going to be the first rainbow. Please, 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 when you do your factor pairs, put the smaller number on the left side of the rainbow and your larger factor on the right. If you have a 4 and a 4, something like that, a 5 and a 5, those are always going to go in the middle when you have doubles. Okay? All right. Pause this video if you need to keep working. Otherwise, I'm going to move on to question number 3. 3. Circle the prime numbers in problem 2. Oh my goodness. I already told you two of them. One was composite, one was prime. Draw a square around the square numbers in problem 2. And then you will... Oh, what is that? Oh, no, that's it for that one. So you're going to circle the prime numbers. Prime numbers are the ones that only have one rainbow. And you're going to want to do these 3 before you do this problem to know. And then it says, draw a square around the square numbers. Man, what is a square number? Oh my goodness. Well, what would a square be? That would mean that this side and this side are the same. So if I had maybe a 4 times a 4, that would be a square. That would mean my rainbow has one of these in it, where I go from one number to the same number. And guess what? That's a square. Oh my goodness. So you could draw a square around that one. And there is, not to say too much, there are 2 other squares on question number 2, just to let you know. So you know that there are 3 squares altogether, okay? And I'll let you find them. But if you do your rainbows and you find that you have 2 of the same in the middle, just like this one, then you know that this is a square number. Because if you draw that out, it will be a square, right? And that could be 5 and a 5, a 6 and a 6, a 7 and a 7, so on and so forth, okay? Pause the video if you need to. Question number 5. Judy has a collection of 30 stamps. She can divide the stamps into 2 equal groups of 15 stamps. Oh, is that true? So she has, oh wait, I'm on the wrong question. Maybe we should start with number 4. Is the number 25 prime or composite? Okay, prime means that you only have one factor pair. That would be your one rainbow. And a composite would mean that you have 2 or more, and I put a little plus there, okay? So if you had 3, it's still composite. 4, it's still composite. 25. So you need to figure out if you have more than just 1 and 25, if there's anything else, if there are any other rainbows that you can add to that. And I'm going to let you work on that one, okay? But how do you know? If you draw out the rainbow or rainbows, then you will have the answer on the paper already, okay? Judy has a collection of 30 stamps. I love to find the numbers as I read. She can divide, right? We're breaking it up. We're breaking up these 30 stamps into 2 equal groups, okay, of 15 stamps. So that means she's got 30. She can take it and she can split those stamps into 2 groups of 15. They're even. And is that true? Yeah. 15 and 15 gives you 30. What are 2 other ways she could divide the stamps into equal groups? Okay. Couple ways you could do this, right? If you wanted to go with our theme, the factor rainbows, you could take the number 30 and you could think about it this way. We did 15 and 15. So we did 2 groups of 15. Okay? That is another factor. 2 times 15. So we did 1 group of 30, and then we did 2 groups of 15. Well, you know what? You can also do 3 groups of 10. And you can also do 1 more. Do you want to pause the video and figure out what that is? If you are looking for maybe just a little bit of extra help, what if I gave you the first number, 5 groups of something? Do you want to pause the video and figure out what that would be? 5 groups of what would give you 30? If you counted 5 groups of 6, you would also get 30. So you can do 1 group of 30, 2 groups of 15. You could do, I better make the colors match. We said you could do 3 groups of 10. You still get 30, right? There's our rainbow. and then we said that we could do 5 groups of 6. You still get 30, and everything is perfectly equal. Okay? Boom, the power of factors. Okay? I didn't mean to do all that one for you, but I did. I'm so sorry. Hopefully you paused the video and you did it before I did. Challenge question. I wonder why this is a challenge. Judy's brother Sam, so her brother Sam, has a collection of 96 comic books. What are the 10 ways Sam could divide his comic books into equal groups? Oh my goodness. Well, you know me. The whole point of this page is to get our factor rainbows on. So I'm going to leave lots of room since we need 10 different ways. I'm going to put a 1 and a 96 right here. I also know that since this is an even number, right, that 2 is also going to be a number that we need. And I also know, just as a little hint to you, that 3 is going to be another one of the factors. So I'm going to give you 1, 2, 3, 4 of the factors. I kind of hinted at factor number 5, and I hinted a little bit at factor number 6. Okay, so that is pretty close to halfway for you guys. Okay, getting to 10. See what you can do. You're going to figure out what 2 numbers, when you multiply them, gets 96. Okay, and this is one that I would love for you to tackle on your own or with the help of an adult. See what you can do. Okay, hope you guys have a great day. I'll see you soon.